Welcome to part 3 of CNC for beginners. Sorry for the long time it has been taking before I make this video here, but I have been sick for a long while and now better and ready to rock again. So in this training we will work with Peck drilling, we will look at subprogramming, but we will also take a look on traditional programming, and that is because there's a lot of G codes for different types of drilling, and but not all offline controllers and software can handle this type of G codes. So that's why we will cover one, the G83, and then the traditional way to drill with, as we did in the mid of the 80s. So let's get started. And first of all, we will talk about G83, which is a Peck drilling command. We will look on M98, M99, which is subprogramming, and we will look at the O, which is a line number, and we will look at P and the L, which is program line and loops, which is combined these two with the M98 command. So as I said, G83 is Peck drilling, M98 starts a subprogram, as I said, can be combined with P and an L. We will look closer on that one. Then we have M99, it ends the subprogram, it goes back to the M98 line plus one line down and continue from there. O was line number, P is a reference to which program line number to go to. L is loops, and with loops it means how many times it should run the subprogram. If we set L5, it will run the subprogram 5 times. If L not is represented or L has L1, it will only run the subprogram 1 time. And then we have the traditional programming, as we did in the mid of the 80s, where we not had all these G codes as we have today. This will always work, the traditional programming, but it takes more time. So the item we will work on today is a bracket we have received. It's from a company who needs exactly 2 holes here, one here and one here. Our center of origin will be here, and this is a coordinate, and the bracket is 12 millimeter thick. First of all, we want to look on the Peck drilling syntax, and the G83 can be combined with some letter codes. We have X, Y, Z, R, P, Q and F codes. What we want to demonstrate here on this bracket here, which is 12 millimeter thick, we have our end mill here, and we want to make this hole here. So how do we do that in a combination with these letter codes? Well, let's take a look. The X and the Y, that's an optional thing. This is the coordinates to the hole, and this is the X and the Y center here of that hole. Honestly, I never use them. I like to place my tool in a line before that to avoid some mistakes. This also makes it easier, at least I think so, when we are using subprograms. Then we have the set. The set has nothing to do with how it is placed up or down on the set axis. It is the depth of the hole, and because we will drill through here, it will be 12 millimeters, the set value. If we only would have been digging down to 6 millimeters, set would have been 6 millimeters. Then we have the retract value, and you can see here this is a distance from the end mill to set 0. And this definition is because when we do Peck drilling, we will retract the tool. In my case, if I may only do wood, but if it would have aluminium or steel, we want to get rid of the chip that is attached to the drill. Because I'm doing in wood, I would activate my M8 command and blow the tool for wood chips. P is dwell time, and that means if we are, as an example, 4 millimeters down to the hole, and we have chips coming out, you can add a dwell time in milliseconds. This means if I add a P100, the end mill will be in exactly that position on each peck for 1 second. And why do we do that? If we are working in aluminium or other metals, we maybe want to break the chip so it's not getting longer and longer and be curled into a lot of things. So we just put in a dwell time, and that will break the chip, and when it's retracting, it's just be taken without and falling off. Then we have the depth of each peck, and you can see here, if I have these 12 millimeters, we have defined set as a depth of the hole on 12, and I say I want to go 4 millimeters. Then the program knows that it has to peck down 3 times, because 4 times 3 is 12 millimeters. So every time it will go down, it will retract up and get rid of the chip, then it will go 8 down, then it will retract, get rid of the chips again, and then it will go through, up, retract, and end the cyclus. That is how it works. Then we have the feed rate, and the feed rate is in my case always millimeter per minute. It's a G94. And here I would use probably between 200 and 300 to push through this cutting cycle. And again, we will now move to NC Viewer, where we will take a look on this and make some program samples and drill these 2 holes in our bracket. So we are back in NC Viewer. You can find the link down in the description. I will start with the start script, the setup codes, and things that we learned in the first tutorial, the first training. And we are working with 12 millimeter hardwood. We will use an 8 millimeter end mill, and we have a safe set on 20 millimeters. The setup code is G21 millimeter mode, G90 absolute distance mode. You remember that means if this is our center of origin, which it is, we work all the time from that and out, which makes sense on these 2 holes that we need to make in this bracket. Then we have G94, which is millimeter per minute mode. This means if we set a G01 F200, we will move 200 millimeters per minute. On addition to that, I have put my axis compass down here. As you remember from the first training, if we go in this direction, it's a positive direction. If we go this on the X, it's positive. If we go up here and out here, it's X positive minus negative. So this is just for wrapping up what we learned in the first tutorial when it becomes positive and negative. It's for your reference. So let's get started. And first thing, I think we will do is to raise the Z-axis with G00, Z20. And you remember, if you put plot in here, then you should see it here now. Wait, there we have that one. And now we go, the tool comes up here. 20 millimeters, that is our safety height. From there now, we will go to the first position, which is X30 and Y40, both in positive direction. So we go G00, X40, was it X40? No, it was X30, and Y40. Plot that one. There we go. So we have placed our tool. Let me see, we do like here and here. So this is the center of a region, and we move out here and are still at Z20. I want to go G00, Z1. Okay, this means we go fast down, and then I will do G01, Z0, F200. So why I'm doing that? Well, to save time, if we have 100 brackets to make, then it is really needed to use the speed as fast as possible. And here I stop 1 millimeter above the item, and then I go the G01 to Z0, because it's easier for me now when we need to create our manual pecks here. And I do that with an F200. So now we are exactly just touching the item, the bracket. So we will now continue. It's a 12 millimeter hole. My plan is to drill down 4 millimeters, then go up, get rid of the chips, drill down to 8 millimeters, up again, get rid of the chips, then down again to 12 millimeters, and we are done. So the process will be G01, Z-4. We let it be on F200, because I think that's good drilling with the end mill. Then we say G01, set, well, it's because I put the caps lock, Z0, now we take the tool up, get rid of the chip. Now we say G01, Z-8. We are still running in F200 because we are running in G01, so it will be read as F200 even we not do any changes to it. And now we go up again to 0 to get rid of the chips, and we say G01, Z0. And the last attempt is G01, Z-12. And now we are down in the depth, and we go G01, Z 0. From there now, we are now done. We have been breaking through the let me see here, we should have been breaking through the, here, you see? Let me see where we are. There, you see we are breaking through the item here, okay? And we are now back to the surface, which is here, and I want to go G00 set 20, which is our safety set. And now we go to the hole 2, which is over here, and it is X80 and Y20. So we have now lifted our tool to set 20. So we go G00, or 0 is also okay. We set X80. X80, Y20. Now we are exactly here above the second hole, and we can now say again the same here. We are in this position, and what we want to do now is we want to copy this section here, exactly this part, and doing like that, and go to this point, and this is exactly now the second hole, okay? Of course this creates, if you have many holes, it creates a lot of lines. Right here now we are lifted up, and I could put an M30 because we are done with the plate. So as you can see, this creates a lot of lines here. So let me just plot it in here. And as you can see now, we have done these two holes exactly as we should. It's we should be here and here, exactly this one and this hole here, and that is what we have drilled now with our 8mm end mill. But we could also use M98 and M99 for quitting this. This would, matter of fact, save us some program lines. And I will in this case remove all this. Okay. And hole 2, I will say this one we need to remove. Okay. And I will call this let's call it 500. Okay. And instead of M30, I will now have M99. So right here, what's happening now, let me close here. What's now happening now is that we are exactly above the first hole here, 20mm up in the air. And I now use my M98. You remember P was for program line, and this refers to the O500, so it will be the 500, so I add P here and 500. Then we had L for loops. if I would have more than one loop here, as example 2, I would move twice from this position down here, that's the first loop, back again, and one more time. It doesn't make sense here, and I not really know which situation, but it could be situations where you want to go 2 times through a subroutine. So, but right now we have told the subroutine to go to line or position 500, which is here, and run all this. When it comes to M99, it goes back to this line +1, this one. And here I want to say we are, let me just check, we are up in set 20, so we will move to this hole here, which is G0 G0 X80 Y20, and when it's done with that, we again will go to M98 P500. So we jump here to hole number 2, and because we are there, and we run the sequence again, M99, and right now we will get an M30 program held. So we have one drawback here with NC viewer, because it cannot handle subroutines. So it will just run through the process here, and one time, and that's it. And let's see how that looks. It looks like that. Let me see. It moves out here to the right position and here, but it's only the last one, and that's that hole here which is shown. But it will do, trust me, exactly as the first old-fashioned code. It will go out here, move down, as exactly the same here, and then do the 2 holes. Then it will go back to this line and say M30 program stopped. But we have a third possibility, and that is to use the Peck drilling command G83. And as you remember here, we had these different parameters that we can enter, and we will still use the M98 and the M30, and just for fun. So you can, matter of fact, let's create it just right in here. So we say G83, and you remember we had the X and the Y. We don't want to positioning the tool, because that we do here before we go to the subroutine, and I don't like using the X and Y coordinations here. I want to have control, move my Z axis up and then move. A little bit old-fashioned, but you can do as you want. You can use it, but I don't use it. So I will have the thickness, the depth of the hole, which was the set command, and the depth of the hole was 12 millimeters. Then we have the retract value. The retract value was the distance between the tool and the top of the item, and it was R for retract, and let me give it 2 millimeters. That's enough to get rid of the chips. Then we had the dwell time. In this case I don't need a dwell time, but if I wanted, it would be a P, and let me say 100. It's 1 second, because we are talking about milliseconds here. And then we have the Q command, which will say how deep do we want to drill on each peck. And I have a 12mm item, so I will go for 4mm. This means we will peck down over 3 times. And then the feed rate, and here just for safety I will enter the feed rate, call it 250 maybe, and that's it. This single line is matter of fact containing all this information we entered manually in the 2 past scenarios. So what's happening now? Well, it's quite easy. We have the program start here, we go up to 20, we're positioning our end mill right above the center of the hole here. Then we say M98 P500 and we start going down. So it will go through set 12 and make the first peck going through here. Okay? Then we go back to this line, go to the next line, and we are saying X80, Y20. We're positioning us here. It's not shown how it should be in the chart here, yeah? Because we come from there and we move to here. Then it again says M98, it goes to this line, jump down here, do the peck 3 times, get the M99, goes back to this line +1, and see the command M30, which means we are done. And this is a much shorter code to build. Again, it's only 2 holes here. It could also be a hole that maybe only should be, let's say, 6.1mm deep as an example. And this is quite easy to do on this way. We could also have made this small program without the subroutines, and it's quite easy to do. I will copy this line here and we take it in here, right there, and then we take it in here, right there. Then we can erase all this. Of course, this is the easy part. Let's plot it out. Here we go. And you still need to see it drill down, which will do for sure. So now you know how to use the G83. You need to do it on the old-fashioned way, and you can do it with some of the code from the old-fashioned way and a subcommand. And you should have learned different ways now, which should suit your needs. Thank you for watching, and stay cool and program a lot.